Some of the exponent laws that you may have forgotten is how to change radicals to exponents. So in this question, you see that we have a cube root of 2 in A. We're going to need to change that to a power. Do you remember how to change radicals? This will be 2 to the power 1/3. So that's one of the things that gets added in these questions. So in A, we have 2 to the x equals 8 cube root of 2. And our goal, just like we did in example 1, was can we write everything with the same base? So if we look at our numbers, we've got a 2 here, and 8 there. Does that happen all in the same column of our powers chart? Yes, that's all in our powers of 2. So we can change our 8 to 2 cubed. We can change our cube root of 2 to 2 to the 1/3. Now, on the left-hand side, we have a power with a base 2. On the right-hand side of our equation, we have 2 powers of base 2. So we also have to think back to our exponent laws. What do we do when we're multiplying 2 powers together and they have the same bases? What was the rule? Add the exponents. So we're going to have to add our exponents here. How do you add fractions? Need a common denominator, so 3 is the same as 9/3. Add the 1/3, and we get 2 to the x equals 2 to the 10/3. Now that we've got both sides as a single power and both sides with the same base, if they're equal, it means that the exponents have to be equal. And in this case, life is really simple. We don't even have to do any more math. If the exponents are equal, we know that x has to be 10/3. No problem. For B, we've got the square root of 125 to the 2x plus 1 is equal to the cube root of 625. So the first thing we're going to look at is, do those numbers appear in the same column as our powers chart? Did we go that high? I'm curious. Did I go that high on our powers chart for 5s? Did I go all the way up to 625? Yes. So we see that in our powers chart, 125 and 625 are both powers of 5. So we can go back to this question. And we can change 125 is 5 cubed. I'm going to keep that in the square root right now, just so I can do one step at a time, not doing too much at once. I'm going to keep the cube root there and just change my powers. Now, a square root can be written as a power of a half. So we've got a lot of powers going on here. We've got inside 5 cubed. That goes to the half because of the square root. And then the whole thing is to the power 2x plus 1. And then on the right side, we have our 5 to the 4. The cube root is the power of 1/3. Lots of brackets, lots of things happening here. On the left-hand side, when I have a power to a power to a power, everything's going to get multiplied together, because that's your exponent law for when you have a power to a power, you're going to multiply your exponents. Now, you can try to multiply all 3 of those at once. Probably, I would suggest, if you're taking your time, multiply the 3 times the half. How do you multiply fractions? Multiply the top of your fractions, multiply the bottom. So I'm going to get 5 to the 3 halves. I'll still have the 2x plus 1 here. On this side, when I multiply, again, this is 4/1. I'm going to get 5 to the 4/3. On the left side, we have another power to a power. When I multiply that, I'm going to have to distribute. So I'm going to get 5 to the 3x plus 3/2 equals 5 to the 4/3. So my goal at first was, can I work with my exponent laws to write both sides as a power with the same base, a single power with the same base, which I've done. Both sides are powers of 5, and if I have powers of 5s on both sides and they're equal, well, that means that if those powers are equal, those exponents have to be equal. That's the only way that it makes sense. In that case, this time I have more math that needs to be done. Because if the exponents are the same, then 3x plus 3/2 equals 4/3. And now we have to solve for x here. So if you're solving for x normally, one of the things you could do is subtract the 3/2 on both sides. But if I'm subtracting fractions, I'm going to need a common denominator. So I'm going to change my 4/3 to 8/6, my 3/2 to 9/6. Which leaves me with 3x equals -1/6. Dividing both sides by 3 is the same as multiplying by 1/3. In this case, I think multiplying by 1/3 is easier mathematically to do than divide by 3 because you're dealing with fractions. And when you multiply fractions, multiply the tops, multiply the bottoms, and we get x is equal to -1/18. These are both good examples because if you tried to guess and check to see if you could get them to work, chances are you're not going to think of either 10/3 or -1/18. You're going to need a technique, a method to do this. And we're using the same method that we did in example 1, where we try to get both sides as a power with the same base. Once you've got a single power with the same base on both sides, you're able to say, since they're equal, the exponents have to be equal. And we showed that by drawing the green boxes in the equation. Because once we got that power with the same base on both sides, then those exponents have to be equal. And on our first example, it was easy because x was already by itself. Our second example, we still had to do some basic algebra to solve for x. But it does feel like we're doing a fair bit of math here and reusing some of our basic algebra skills for solving for x. So we're going to do a couple of these, 9 and 10 right now.